Good evening, everybody. I'm glad that you came today to hear something about the layouts. My name is Artem, and I'm a full-stack developer from Ukraine, not Russia. I'm currently living in Prague. I've been incredibly lucky for the course of a couple of previous years to work with great technologies. And today I would like to share one of the conclusions I drew from my work. And that is basically no matter how modern your stack is, it's still about the UIs we built as developers. So as a part of this talk, I would like to share with you my experience and maybe provide some interesting patterns on how to build flexible and maintainable layouts in React. Let's start from just defining what layout is. According to definition, layout is the arrangement of different elements on the page. But we can also put a more practical definition, which would say that a layout is a combination of components and the spacing that defines the relation between those components. So let's analyze these two things in more detail. So components. I think the community has done a great work in developing really flexible and customizable components, which you can find in open source all over the place. And I think they're really great. And this is not something I would stop and focus today. But what I would focus on this is spacing. Now, spacing is often perceived as something abstract. And in fact, I believe that spacing is the biggest problem that causes highly non-maintainable layouts in our applications. So I will give you a quick example. Let's say we have this simple layout of 3 boxes. And the requirement is that we need to space them out equally without any space going outward. So this is just one of the ways we could do it in CSS. A few lines, pretty simple. But the problem comes when we deal with some change request. For example, a client comes tomorrow and says, hey, we want to move this green box just about, which would be nice and shiny. And if we just do that, suddenly no spacing makes sense and everything just breaks. I'm sure that once in a while you find yourself in this kind of situations. And I believe this isn't how layouts and spacing in layouts meant to be. And particularly for this problem, I can give you a small advice is that, yeah, don't write a lot of CSS, definitely, to cover that up. But this is one of the results of these problems. We just end piling up a lot of CSS to cover different use cases. So the advice for me would be stop coupling spacing with your components. And it may get a little controversial at first, but I think this is a really interesting approach in layouts. Probably we need to also define what is a good layout then, what we should do. I believe that a good layout is first of all scoped. So implementations we do in one place shouldn't affect anything else which is defined elsewhere. So they shouldn't break it, for example. Also, a good layout is maintainable. So it's easy to add things, move things, remove, and so on. And in my opinion, it's also contextless, especially regarding spacing. So the components which are in the layout shouldn't be really aware how they are spaced. That shouldn't be their responsibility. So you may be wondering is there any solution right now to cover these problems and to achieve great layouts? Well, I can tell you that in fact there is, and it may help deal with some of those points. And this solution has been around for years, and it's already on your phones and your laptops, and it's really well supported, and it's called CSS Grid. I don't know if you're familiar with it. Maybe you can raise hands who used CSS Grid or heard about CSS Grid. Pretty decent amount. Just maybe for those who haven't heard about CSS Grid, basically CSS Grid is a 2-dimensional display model which allows you to position your elements inside the predefined grid in a really smart and flexible way. It has really great browser support, and as a fact of me speaking right now, I'm sure that it surpasses more than 88% of browsers worldwide, which is huge. So in general, I highly encourage you to use it. It's stable, it's standardized, and it's already running. But I was wondering, can we use the power of CSS Grid and combine it with all this flexibility and benefits of JavaScript and React in particular to supercharge our layouts? And I'm really excited to share my experiment which I did, which is called Atomic Layout. So what is this experiment about? Basically, Atomic Layout is a physical representation of layout composition. I can give you more example here. So let's compare Bootstrap, which we're pretty much familiar with, and Atomic Layout you just heard. So in Bootstrap, you usually have a set of defined columns which act like rulers, which you can snap your components into. But sometimes the problem comes when you need to make a little component in your layout, and this isn't really the use case where you would bring the whole grid. And in atomic layout, I was trying to envision the composition in a slightly different way. So we can say that a page may consist of header, some main section, site, and footer, and then the header itself can be a composition of some logo, menu, and some actions on the right, and then the menu can be a composition of list items, and so on. So, and we of course can create a conventional grid system because grid is just a composition of rows and columns. So we can say that it's like a grid that goes all the way down to the furthest leaves of the interface tree. And the core benefit is that it remains predictable. I can give you another example, more practical one. Let's say we're about to implement this tweet component on the left using atomic layout. So what we would usually do, we would import the composition component because now it's a physical component exposed by the library, and we would define a template string of how this layout should look like, and we would use just plain words, so it's easy to parse by the eye. So we would say that our tweet component has the avatar section, which takes all the left of our component, then it has the header and the body, and as you can follow the highlighting, once we define these areas and pass it to composition, it actually exposes us a function which has all these areas generated as React components, so we can render them. This so on goes for attachment and footer, and since it's React and we all favor composition in React, we can nest another parts of layout inside a footer, for example. So we can say that footer is a composition of it's a list of items with the icon and text near it. Important message is that it's just the example of how CSS Grid can be utilized, but there is no intent to replace CSS Grid for you. So you are still encouraged to use CSS Grid in apps just as you would normally do. And I would like to highlight a few things which atomic layout encourages you to do to create really stunning and good layouts. So one of these things would be unification. Imagine if you can go to any part of layout in your app and you can instantly understand how it looks like, how to change it, and how it actually renders if you change it. So this is basically all atomic layout is about. You have two main parts, which is a template definition and the rendering part, where you render your components. It also favors nesting your composition, because if composition is a physical component, you can pretty much nest it at any point of the tree you want, and this is great. So any layout composite can be a composite and a composition. It's also about configuration, so our layouts would stay consistent. So we can configure layouts on the app basis, so we can change things like default unit, to use rems instead of pixels, for example. I'm a huge fan of basing spacing on my typography. We can also specify some default breakpoints in case we can't go mobile first, and we can define a custom breakpoints just using the default options you would use in CSS for media queries. There are also a few things to speed up our development life, and one of those would be prop aliases. So it's a really simple concept, basically a string analysis which compiles certain properties into corresponding CSS. So in case we have padding vertical, we would have padding top and padding bottom in the end CSS. Another feature would be responsive props, and this is something more difficult. Basically, atomic layout would try to understand your prop name, and in case it contains the breakpoint, which is medium here, it would know that the value of this prop name should be assigned only on medium breakpoint and up. But in case you supply an optional behavior, like only or down, it will also be taken into account. So in this case, we would have the gutter only for medium screens, medium breakpoints. And of course, as React itself, atomic layout is also highly adoptable, so you can try it out in a small part of your app and then maybe expand it. I think I said enough of interesting things, and it would be cool to give you some short demo of how it actually works. So let's say we have an app, and inside this app we need to render a list of apartments, a list of flats. So it's pretty easy. We'll keep them in some JSON. We have a flat list component which just iterates over these items and renders the flat component. And then the flat right now is just a paragraph with the title of a flat. So we have 4 flats. So how would we approach this if we were creating this layout? Well, with atomic layout, it would be simple. We would import the composition. And as the second step, we would define how do we want our layout to look using just words. So let's say we want a mobile template, our mobile flat component to have a thumbnail. Then some heading right underneath, and then some actions section where customers can book our flat or see where is it on the map. And then, as the render part, we can just render this composition and supply this template string into the template prop, like that. So by doing that, we would be exposed a function as children, which has all these areas generated for us. So we would include thumbnail, heading, and actions. Yeah, so we can pretty much render anything we want as a children of these generated areas. So I can render some white button here, which would say book. And once I hit save, we can see on the left that immediately our flat component just became the areas we described. So we have the thumbnail, the heading, and some actions. Now I'm gonna just use a few predefined Atom components to make it look more visually appealing. So I would wrap it in a card component and use the image component here. Yep. Yeah, that should be enough. Yeah, so once I press it, we already have some visuals. But as you can see, there isn't any spacing going on. So the components we just used, our atoms, they are not aware about how they should be spaced and what is the relation between them. So we can just configure this in the composition. So we can start from saying that our flat should have a padding, let's say, of 15 pixels. We can save that. Nice. And then we also want to space out these areas we have, so we can use something called gutter for 15 pixels as well. So we have this nice flat component right now with the spacing, but the important part is that we delegated the whole spacing into its own layer, which is our composition. And now this basically, because of this delegation, we don't have this problem that something may break. So if we want to move our heading above the thumbnail, we can just move it in the template string and just save it, and it's right there, and nothing is broken there. Okay, this is all great, but we can move it even further, and if we think about our flat list, well, essentially it's just a composition of flats. So we can apply the same pattern here. So we can import the composition and render it here. Now, for this use case, I wouldn't say that we need any predefined areas because all the children will be the same. So we can just render composition as is without using the function as a children approach. So right now it would do nothing, but in fact it just wrapped it in a CSS Grid container. So we can use the same properties we would use in plain CSS to specify how the CSS grid should look like. So we can add things like gutter, for example, and this will space the flat components in this list. But we can use a lot more. We can specify, we can center our children, so like justify content. And we can also specify how the CSS grid will behave. So we can use something like template columns. And we can use a really great auto-fitting algorithm, which I will demonstrate in a second. So basically, we can tell our grid to try to put as many children as possible if there is the certain amount of space available. And on practice, this would look the way that, okay, we have just one column and components, but when there's more spacing, more components keep rendering up. And this is done with just one line of CSS, and you don't need any libraries or React whatsoever to do that, which is really great. So on larger screens, we can have 3 items. On really large screens, we can have 4 items, and so on. So it's really handy to have the power of CSS Grid in our disposal. Now let's think a little bit about the responsiveness of our implementation. what we can do is we can specify that, for example, we would want on the medium screens to have just 2 columns of equal size. So we can go there, and we can use a responsive prop. So we would suffix our template calls with MD, and we can specify that for this breakpoint, we want to have only 2 columns with equal size, which is 1 fraction of space. So we have it here now. So we have this kind of layout with auto placement, and then completely another layout on the next breakpoint. And now let's dive into flat component more. There's surely more we can do. So for our template users, let's serve slightly different layout. Let's go more horizontal because we generally have more horizontal space here. So we can say that let our thumbnail go all the way left, and then the heading and actions adjust right next to it in the next column. And we can pass this template string template MD and just hit that save. Now immediately things change, and this doesn't look fancy, but actually this is just us needing to describe how CSS Grid should position these columns we specified. So we can use the same prop template calls, and we can say that the first column, I think you can go with, we can use min-max. So we can specify, for example, we don't want our thumbnail to be too small, so we can say like, hey, like not less than 100 pixels, but you can take more, definitely. And then the right column could be just 1 available fraction of space. So we can have this kind of layout, which will be sticky, so our image will increase in size, but not less than the minimum we specified. And this is again just the CSS specification, so you can use it right now. Now this button here doesn't look very good because it's different depending on the content, and we all been there. And this has already been solved with flags. And we can use this property here. We can align the actions area to the very end of our flex box just with 1 property, and we would have our button sticking in the bottom always. So we have something like this right now. Pretty good, but I would say that responsive is also about conditional areas. So it's often we want to display some content on a certain breakpoint or from a certain breakpoint. And this is also taken into account with atomic layout. So we have the only component, and let's say we want to display another button here near a book. So we can write only, render our button, to be a button map. And we can specify that we want this to be rendered only from a certain breakpoint, like medium. And once we save it, we see that there is 1 button appeared. And on the other breakpoints, it's just not there. And we can make this whole area behave like a flex box, so it applies to the children by simply putting flex prop, and this will align our buttons together. And since all these generated areas components inherit from the same model, they all support this kind of prop aliases. So we can use something like margin right with 10 pixels just to space those buttons a little bit. So this looks pretty nice for our new conditional button. And the next step would be thinking about our desktop users, like how to serve content for large screens. Well, interesting approach I would find is that we can reuse the same template definitions for different breakpoints because they're essentially just describing the relationship. They're not bound to which kind of device is being displayed. So you can use the template mobile for the larger screens. And yeah, so we just pass the same template, and if we go to the larger screens, we can see that it starts to behave the same way as on mobile. But now this column behavior gets in a way because this is not what we want on our large screens. We don't want to be restricting our content. We want it to be fluid. So we can easily fix this by providing the only behavior to this whole property. And once we save, this no longer applies. But again, we can also change the way our content is added, and we can use this auto-fitting for larger screens where our components can take advantage of the space. So we can specify how they behave on the large screens. Auto-fitting. And we can allow them to take more than 250 pixels if they're needed. One more parenthesis, yes. Yeah. So we would have the auto placement all on big screens as well after the medium, using the same template definition we had on mobile. Of course, with our conditional areas preserving and so on. So in the end, we would have a layout like that has some auto placement, and then completely different position of elements with responsive and conditional elements, and then reusage of the same layout on larger screens, like this one. So this is just a quick demonstration. It's been just a proof of concept for me and should serve like a demo of how you can utilize the technologies to just be in a new level of spacing in your applications. So I can also share some internals of how this actually works, so convince you there is no magic. Currently it's built with React and style components, and it uses React Responsive for these conditional areas. One of the biggest things Atomic Layout does is that it provides the areas generation. So whenever you create a composition like that, and you pass different template strings to different template props, Atomic Layout will first create the list of all the areas being unique, so header, sidebar, and footer, and then it will create the templates list, which is slightly more complicated, and it will basically match each template pair with the corresponding breakpoint, which you can see here. So we can see that header and sidebar should be rendered on an extra small breakpoint going up, and the header and footer should be rendered on a medium breakpoint also going up. And as the next step, it will reduce this list into a map of components. And as you can see, our header was present in both definitions, so it will not be conditional, so we will receive it as is. But footer and sidebar, they are different. They should appear in certain breakpoints, so Atomic Layout would wrap them in the media query from React Responsive, so you just get this wrapper built in. And the responsive props, it's just analyzing of the strings of the prop names. So let's say if you have a retina breakpoint and you specified some resolution there, like 300 dpi, when you provide a gutter retina prop, Atomic Layout will understand that there is a retina suffix, and it will generate the proper media query in CSS. And since we supply the only behavior, it will also be smart about it, and it will kind of enclose this media query, so it will not go beyond what you specified. So in this case, it will be from 300 to 301, and gutter as a prop alias will compile to a grid gap of 20 pixels. So as the result of all that, we have a really powerful technologies utilized like React and CSS Grid, and also a few time savers like prop aliases and responsive props. And they allow us to have unified layout implementations, which consist of template definition, which describes how our layout looks, and the rendering part, which just configures the spacing. It's all scoped due to CSS and JS solutions, for example, style components, so we are not going to break things accidentally. And it also favors React compositions, so we can physically compose our layout, our composition dedicated for spacing via React. And it's of course responsive by default. You can try it right now. It's available on NPM. As I said, it's just a proof of concept, but I would really like if you give me your feedback, what do you like or don't. And I put up some resources for you. You can check out the GitHub repository and the documentation on Gitbook, just to help you get started about this concept and maybe to give you some recipes and patterns on how to apply it. And again, as I said, it's not about Atomic Layout or specific libraries. It's about rethinking what implementational part the spacing should take in your applications. So I hope I encourage you to challenge layout implementations, and thank you.